All right, welcome back everybody. We are now at Lecture 7A, and the first part of the tape today we're going to review for Test 1, and the way we're reviewing is that I have collected problems from the group that's in here, and we're going to work through those problems and answer questions. Reminding you that Test 1 covers Chapter 2.2 through Chapter 3.1, plus your supplement regions bounded by curves. And you're guaranteed that there's a region that's bounded by curves on your test. It's a very important calculus concept. There was a couple comments. The test is no calculator. The test is no calculator. I want to remind you at the end of Chapter 2 in your textbook, end of Chapter 2, this is page 288, there's a lot of review exercises. A lot of review exercises for practice. They just keep right on keeping on. Actually, more pages than probably what you want. Gosh, it looks like about 4 pages of review exercises. Notice on page, and in your student pack that you got, there is a student solution manual, and so I am pretty confident that the review problems, let me just double check that because I want to tell you the truth. Let's see here. That looks like a question 101, so I bet that's from the review. Yeah, your Chapter 2 review, it has worked out in detail the odd problems in your solutions manual, so I would say work those problems out and then use your solutions manual to double check your work. I like that it shows you all the steps. The back of the book just gives you the final answer. And let's see, I think I saw a chapter test worked out. Chapter 2 test. Of course, your test is going on into Chapter 3. However, if you'd like to hear somebody work out all these problems, in your student pack, as you remember, was a disc. Which is the chapter test prep videos that came in there. And when I put it in my computer, it was somebody actually working out the chapter test questions for you. So you want to use these as checking yourself. If you just sit there and listen to somebody else do it, that's not going to go to your long-term memory. You want to work them out ahead of time and then check yourself with the videos. And these videos you can just kind of fast forward across the bottom and move on if you're wanting them to get going. Okay, so did I say all the things? It's no calculator. Be sure that you've taken good notes and can rework every example I've done in class without looking at your notes, because in class I'm telling you the things I need you to know how to do. And then your homework from your textbook, WebAssign, those are reinforcements to help you master the content. Okay, but don't ignore the notes that you take in class. All right, I think that takes care of that, and I have collected a lot of problems from you guys that are in here with questions, and I'm going to go through those, and don't forget, chime in if you want to talk about something else related to what I'm doing. All right, the first big question, this is in our review section. I mean, this is us reviewing. First question that many of you had was the difference quotient was running you crazy. F of x plus h minus f of x over h not equal to 0. This is definitely on your test. It's I'd say 99.9% sure, since the tests change every semester, but I've never made out a test yet, I don't think, that didn't have the difference quotient on it. It's very calculus related, and it's always on the final exam because you need it for your calculus course. All right, as you'll remember, the difference quotient just gave you the slope of a line between 2 points, slope of a secant line. But in this class, all you had to do was learn how to find and simplify the difference quotient. So let's take an example such as f of x equals 2 plus x minus 3x squared. And the instructions on the test would be find and simplify the difference quotient given this function. All right, so we know that anytime we're going to evaluate f at any element, it's going to be 2 plus that element minus 3 times that element squared. All right, so for the difference quotient, I'm going to have to find, well, what is this function evaluated at x plus h? Well, that's the same thing as if I said, what is the value of this function evaluated at 3? Wouldn't you put a 3 in for x? If I said f at 3, you'd put a 3 in for x. So if you want f at whatever this is, you would just go put in, I wanted red. Well, that's green. Try red. F at x plus h, it just means you put a little x plus h wherever your parentheses is. F evaluated anything. All right, so once we do that, then we can come under here and simplify. So I have 2 plus x plus h minus 3 times, and now I need to square x plus h. And if you square x plus h, it's x plus h times x plus h. X squared plus 2xh plus h squared. And let's go another step where we distribute the negative 3. And again, I want to put this in red because I've seen some of your work already and you're forgetting to distribute your negative. It's minus 3 all the way through. So we have 2 plus x plus h minus 3x squared minus 6xh minus 3h squared. All right, so the step that I've seen mistakes on so far is distributing the negative, or I've also seen this mistake. I'm going to label this mistake so you don't write this down, because then it might go to your long-term memory. I've seen people say, okay, if f of x is 2 plus x minus 3x squared, and you're asked to find f of x plus h, what I'm seeing that is not correct, this is in case anybody's daydreaming, what I've seen people do is write 2 plus x minus 3x squared plus h. Why is that not correct? What is this actually? That is your original f of x, and then you're adding h to it. So it's not the function evaluated at this, it is the function and then you added h. So this is not equal to that. And I think that's where your mistake was coming in. Okay? And that's a mistake that happens, and that's why it's so good to point that out. Does everybody see the difference between f of x and then a plus h and f of x plus h? Everybody got it? All right. So now we're ready to go. We're just going to find and simplify the difference quotient. That's what the test question usually says. Find and simplify. Find and simplify. All right, so in the place of f of x plus h, I'm going to write 2 plus x plus h minus 3x squared. And if you skip steps here, you're going to probably lose a negative or something, so take your time. There's f of x plus h. And now we're going to subtract the entire function, and the entire function is 2 plus x minus 3x squared. Okay, this is another place that I see mistakes, is people forget to put parentheses around the function f of x. It's minus that entire function. Remember, I've been teaching about 27 years, so I know where to look for mistakes on the test. So when I tell you these things, I would mark it in red in your notes so that you don't make that mistake. And then you can all send me a thank you note after your test. Okay? Uh-oh, now I'm going to have thank you notes coming in. All righty. Okay, this is minus this whole thing. You got to be careful to distribute your negative. And at this point, hopefully you see that 2 take away 2 cancels out. X take away a x cancels out. A negative 3x squared and now a plus 3x squared cancels out. Is there any questions on what I did at that step? Anybody? Everybody with me? Okay, so now we're left with h minus 6xh minus 3h squared over h. Okay, now that's a very good answer, except that the instructions on the test always say, and simplify, and simplify. All right, so what's the, this is like a fraction that can be reduced further. It's like if you had the fraction 4/6, you can reduce it further to 2/3. All right, so how do you simplify this? Take out a h. What's the big word? Factor. All right, I'm going to call this the big F. The big F. We're going to factor. So factor out of h, and we have 1 minus 6x minus 3h, and then we have this over h. And the reason I'm factoring is because we know if we have a times b over a times c, a over a is like a factor of 1. So 1 times b over c is b over c. All right, so h times something over h times 1, if you want to think of it that way, the h's divide out because h over h is equivalent to 1. And this is equal to 1 minus 6x minus 3h. Okay, how was that, everybody? Good? Questions? Okay, yes?
Should it be a 6/8x where you did the last step? Being, what happened to the h that was?
Right here?
No, the one that was on the 6x.
Oh, when I factored it
That's
out?
fine. I'm sorry, I forgot.
That's okay. I factored a h out of a h, that left me with 1.
Okay.
And then when I multiply h times minus 6x, I get minus 6xh. Okay. So it's a good idea right here to double check your factoring. Okay. Always double check yourself. Yes?
One of those WebAssign things, like, I worked it out like that, but it said I missed it for some reason.
If you worked it out like this and WebAssign said you missed it, it's a good chance that it was the symbolic notation. You might have to do something like 1 minus 6 times x minus 3 times h. You have to put that little times symbol in there. Do you think maybe you left that out? Okay, and if you'll check with me, I'll pull up your work and I can see. Okay, WebAssign is really picky with the symbolic notation, right, and it has to be. Everybody good? Okay, there was another difference quotient that was running everybody crazy on WebAssign, so we'll do another one of those. All right, so again, we're going to find and simplify. And I give you the difference quotient on the test. You don't have to memorize this. You will have to memorize it when you get into calculus. By the time you do a few of these, you've got it memorized anyway. But in calculus, you do have to memorize, but not for my test. All right, the problem this time is the function f of x equals 1 over x minus 5. You had a question similar to this. Also, we did one similar in class, but want to go back and look at this again. All right, so before we even do this problem, the concern here is how to add fractions. That's what ends up being. So let's go back to the good old days of when you used to add fractions. If you added a third plus a fifth, you were adding, what was your common denominator? 15. So you had to multiply the 1/3 by 5 over 5 and the 1/5 by 3 over 3, correct? And then you got 5 plus 3 over 15. Okay, so suppose you have 1 over a plus 1 over b. What's your common denominator?
AB.
AB. Because You had to multiply this one by b over b and this one by a over a, right? So your answer is b plus a over ab. Is that good? All right. Suppose you have 1 over x plus 1 over h. Okay, so xh is your common denominator. All right. Suppose you have 1 over x plus 1 over x plus h. Okay. X, you're exactly right. X and x plus h are two different numbers. It could be like this is the number 3 and this is the number 5, where h then would have to be 2, right? If x is 3, then that would just be like, and if h is 2, then 3 plus 2 gives me the 5. So x plus h is a different number from x. Everybody agree? So your common denominator here is x times x plus h, right? So here, beside x, you had to multiply by x plus h over x plus h. And with the one with the x plus h, you had to multiply by x over x. So you would get x plus h plus x. Is that clear, everybody? Okay, so this was the part that was the problem, I think, and the concern for the difference quotient. Oh, one more thing might have been a concern. The complex fraction. If you have a fraction divided by a fraction divided by a fraction, how do you simplify that? Right, you invert and multiply, so it's 1/2 times 5 over 1. Divide, it's the same as invert and multiplying. Okay, those are the part with the x and the x plus h plus the inverting and multiplying may be the parts that was messing that problem up. So here we go. Oh, didn't get to copy it. Which would be 2x plus h over this. You have to have like a bionic arm in here so you can write fast, don't you? Got it? Okay. All right, so here we go. So f of anything is going to be 1 over that anything minus 5, correct? And when you look at your difference quotient, you got an f of x plus h. So wherever I have an x, I'm going to put a little x plus h in there. All right? So our problem will be f of x plus h, which is 1 over x plus h minus 5, minus f of x is your original problem. And we're going to divide the whole thing by h. All right, is there a question this far? This is f of x plus h minus f of x all over h. Okay, so now we have to simplify this complex or compound fraction. All right, is x plus h minus 5 and x minus 5, are they the same numbers? They're totally different numbers. So when you get ready to find the common denominator up in the numerator, what is it going to be?
X plus h minus 5 times x minus 5.
You are so good. It's x plus h minus 5 times x minus 5. Both of these numbers multiplied together. Okay? Just like if you had the number 6 and the number 7, or 3 and 8. You just multiply those two numbers together. All right, so what do I need to, I got these pens all mixed up here. What do I need to multiply numerator and denominator by here so that I have this common denominator?
X minus 5.
Okay, so I'm going to do an x minus 5 over x minus 5. Okay? And then the second term here, what do I need to multiply it by?
X plus h minus 5.
correct. X plus h minus 5. All right, so now we're ready to copy. It's going to be x minus 5, and then be very careful not to lose your -1. So I'm going to actually put in the parentheses here. Okay, I've seen this missed on the test too many times. All right, so it's x minus 5 minus the x plus h minus 5.
Do you get partial credit?
Yeah, the question was, do I give partial credit? Yes, your test question says show all work. Now, WebAssign just goes for an answer only, but we want you to communicate your work, and if you made a arithmetic mistake, but then you worked the rest of the problem correctly and you didn't create an easier problem, and you're still testing the same concepts, then you only lose a little bit. If you go change the problem, though, and you're not testing the concepts, then I have to whack you off really hard. Okay? Otherwise, all of you would change all your problems to add 2 plus 3. Right? You still gotta, demonstrate that you've mastered those concepts in your problem. All right, so now, this is why it takes so long to grade your papers. If I was just grading answers only, I'd zip right through them. All right, so let's distribute the negative very carefully through. All right, so x, take away a x, they're going to cancel out. -5 plus 5 is going to cancel out. And what am I left with in the numerator? A -h. -h over x plus h minus 5 times x minus 5. And all this is divided by the h that we have right here. Is everybody good? So down in the denominator, this is really like a h over 1. H over 1. So I have a fraction, a single fraction, divided by a single fraction. Do I see any confused looks here? Yes, what is it?
That part.
This?
No, about that.
This one? X, take away x is 0. And -5, and then you got minus a -5, which is a positive 5. So -5 plus 5 is 0. And I'm left with a -1 times h, or a -h in the numerator. Anybody else? Question? All right, so you tell me when we have a single fraction divided by a single fraction, you're just going to invert and multiply. So I'm going to invert that denominator, and now I have 1 over h. Okay, so when you multiply fractions, remember you're multiplying numerators times denominators. So if you just want to extend this little line right through that dot there for multiplication. Okay, and now what do you know about h over h?
They cancel.
They divide out. So what am I left with now in the numerator?
-1.
-1 over x plus h minus 5 times x minus 5.
And we have to work it out. You want the factor.
Oh, you don't need to multiply that out. Oh, were you working so hard to multiply that out? You don't have to multiply that out. Factor form is always a great thing to have. Okay, now, if you've missed this in WebAssign, my guess is the concern is this. It needs to be -1 divided by, and then you have to tell WebAssign this whole thing is in the denominator. So you first have a big set of parentheses to indicate that it's all in the denominator. And what is in the denominator? The factor x plus h minus 5. And what needs to go between here? That little star, x minus 5. Okay, so notice that I have two sets of parentheses there, but the first group, the whole denominator, and then there's your two factors multiplied together. All right, everybody good on difference quotient? Going to get it correct on the test? Make 100? Answer to that is yes?
Yeah.
Okay. All right, the next question I had was, let me check this off so I know I've got them covered. X and Y intercepts. x and y intercepts for linear functions and for quadratic functions. Okay, remember, x-intercept just means where it touches the x-axis. Intercepts runs into, like intersection of a highway, runs into the x-axis, and a y-intercept is where it runs into the y-axis. All right, so let's start with the linear function. Linear function. All right, tell me the general form for a linear function. F of x, which is y, equals what?
MX plus B.
Mx plus b. All right, remember the exponent on the y has to be a 1. And if there is an x, it also has to be a 1. Because, you know, you could have y equal to 7. That's your constant function that's still linear. All right, so we'll take an example, such as y equals 3x plus 2. If you're looking for an x-intercept, how do you start out looking for an x-intercept? You let y equals 0, solve for x. So you have 0 equals 3x plus 2. And then all you have to do is solve for x, which would be subtract 2 from both sides, divide by 3. So for this curve, this straight line here, it's going to pass through the x-axis at negative 2/3. I forgot who asked me this question, so I'm looking at your face. Who asked me about intercepts? Okay, how's that?
Yes.
All right, now let's look for the y-intercept. If you're looking for the y-intercept, how do you start out doing that? X equal to 0, solve for y, because you want to know where it touches the y-axis, if anywhere. Okay, so you get y equals 3 times 0 plus 2, y equals 2. Or if you happen to remember the slope-intercept form, that b is the y-intercept. Okay? Good? All right, let's go to x and y intercepts for quadratic functions. Do you need me to slow down a second? Yes.
Since there's no calculator on the test, are you going to give us small numbers?
Okay, thank you for asking that. If there's no calculator on the test, am I giving you small numbers? Well, if the numbers come out to be, this is a pretend, this has nothing to do with that problem. If you work a problem out like this and it came out x equals 127 over 13, you just leave it. You don't need to do any long division, just change it to a decimal. Even if you get 8 over 6, I don't care that you simplify it even further. So just leave your numbers exact. You don't have to simplify. Also, if you get even something like square root of 48, I know that could be simplified further, but you don't have to do that on the test. We just want you to get the exact value. Yeah.
What if it says simplify?
If it says simplify, it will, but where you're getting something like this is just solving for x or something, and you don't have to simplify it.
Okay.
But if you're in doubt, ask. But I realize you don't have a calculator, and most of the things like this, I'm not trying to get you to simplify anyway. I'm just trying to get you to solve and show the process. Yes?
But if you do get like square root of like 25 or something, you do want to S5, right?
That would make me feel good that you knew that the square root of 25 was 5.
Okay, I was just making
Yeah,
sure.
yeah. I just didn't need you to say, okay, 48 is the square root of 16 times 3, which is 4 square roots of 3. But if you had a perfect square like 25, I'd feel a lot happier if I knew you knew that was a 5.
What if you did? Maybe just try.
I'll just yell at you off the camera.
What if we give you different answers and you can choose?
That's right. That's right. All right, everybody good? Okay, let's go to the quadratic function for x and y intercepts, and I've just made up one. We want the x and y intercepts. What's the general formula for a quadratic function? F of x, which is y, equals what? Ax squared
Plus BX.
bx plus c. Okay, what's another form that we studied this so you would know how to do your shifting, stretch, and reflecting? A times x minus h squared plus k. You want to know both of those forms because if it's in this form, you already know the vertex, you know how to sketch the graph. Life is great. If it's in this form, you know how to use the formula x equals negative b over 2a to go find the x-coordinate vertex. Okay, but we're working on x and y intercepts, and so I'm picking a problem like f of x equals 2 plus x minus 3x squared. Okay, you might want to write this in descending powers of your x. You might want to change it around where your exponents decrease instead of increase. By the way, tell me what this is the graph of. Parabola, how does it open?
Down.
Downward. Okay? All right, let's go with the easy one first, the y-intercept. Let x be 0. What is it? Y is equal to 2. So we know it's going to touch the y-axis at the point 0, 2. Just let x be 0, so y is 2. Okay? All right, now the more interesting one is the x-intercept. Okay? So we're going to let y equal 0 and solve for x. All right, so we have negative 3x squared plus x plus 2 equals 0. I was hoping I didn't give you something that factored. Does it factor? I don't think it factors. I didn't want anything that factored. Normally you look to see, can you factor, the big F word, as two things multiplied together equals 0. But if you can't factor, what are you going to do immediately? Quadratic formula. So x is equal to negative b plus minus square root b squared minus 4ac all over 2a. What's my a?
Negative 3.
Negative 3 is my a. A is always the coefficient in front of the x squared. What's my b? 1. And my c?
2.
Positive 2. Okay? All right, tell me what to put in. What's the first term?
-1.
-1 plus my square root of 1 squared is 1 minus 4 times negative 3 times 2, the whole thing over 2 times negative 3. By the way, I want to tell you what some people in other classes, but not my class, do. They never can remember if this division line goes over the whole thing or not. So in other classes, people will start right under the plus minus and put the line hoping that the teacher will take it either way. But nobody in my class would dare do that because then you would lose points, right? Because I can't guess what you mean. So make it very obvious. The whole thing is over 2a. All right, so x is equal to -1 plus or minus the square root of 4 times 3 is 12, a negative times a negative is positive. 12 times 2 is 24. Ooh, I did make up something that worked. So that's going to be 1 plus 24 is 25. I didn't want something to factor. Guess that would have factored. 2 times -3 is -6. And make me feel good, everybody knows the square root of 25, right? Plus or minus 5 over -6. So because that came out to be a perfect square, this thing up here would have factored. All right, so I have two values for x. -1 plus 5 over -6, or negative 1 minus 5 over negative 6. And of course, negative 1 plus 5 is 4, so we get negative 4 6. I just carried the negative up to the numerator. 2/3, negative 2/3. And the other one is negative 6 over negative 6, which is positive 1. This thing must have factored up here.
I just didn't see it the first time.
That's okay, I didn't see it either.
It was-
This must be a 2 and a 1,
And then
and this has to be
3.
3x and a minus x. Is that going to do it? That's negative 3x squared, positive 3x minus 2x, and 2 times 1. Yeah, so it would have factored, and you got it. But if you don't see how to factor something right away, just jump right into the quadratic formula and you get it. There's the x equals the negative 2/3, and there's the x equal to positive 1. Okay, everybody good? Are you good on x and y intercepts?
Yes.
Everybody good? Okay, we'll check that off. X and Y intercepts. Oh, that wasn't even the problem I meant to write down anyway. I did the wrong one. Okay, next one we want to talk about is this function. This came off a web assigned question and probably out of the textbook. To reflect about x-axis. To reflect about the x-axis. Let's remember what the graph of y equals x cubed looks like. What's the key points, everybody?
1.
Okay, 1, 1, 0, 0, negative 1, negative 1, but you have to know it looks like this. Okay. All right, so if we want to reflect about the x-axis, that's like we're going to turn the fold the paper along the x-axis. It's a mirror, so it's going to go like this, and that means that part's going to flip up. Okay, so here's the graph. This is like you folded it over the x-axis. You folded your paper here. This part flips up, this part flips down. Okay, that means the y values have been reflected. You kept your same x values, but your y's are now the opposite. So if you want to reflect about the x-axis, your new function will be your old function, but you're going to get the negative y values. So this function, which is my h of x, my reflection, is going to be minus my old function. Okay, that will reflect it about the x-axis. Now I realize that if I multiply this out, that's going to also be equal to minus x cubed. Because x cubed, whatever it is, and then you'll have a minus there. Okay? All right, because that's an odd function. This is the answer I'm sure WebAssign is looking for, probably.
It took both.
Yeah.
It took both? Okay. That follows the definition that you take your old function and you take the negative of the y values. All right. The next part, though, was to reflect about y-axis. All right. So let's go back to our old graph. I'm going to draw a new one for this one. So the graph goes like this. Okay. Now, if you're going to reflect about the y, that means you're going to fold your paper here where the y is. So if you reflect about the y, this part is going to flip over here. Okay, that's that part flipping over. And this part's going to flip over here. Now that looks just like what you just did. When you had that x cubed, you can't really tell the difference, so that really starts to look like a confusing problem. But when you're reflecting about the y value, that is affecting your x values, right? You switched your x to flip it around, switched your x. So your new h of x here, if you're affecting your x's, is really f of your other function minus your x. That means you switched your x in order to flip it about the y. Well, f in this problem, this whole problem is very confusing if you ask me. F of minus x means that you have, where you have an x here, you're going to put a negative x, and then you cube it. All right, but because you are cubing, let me just put in one more step. That minus there is like negative 1 times x. So when you cube a negative 1, you're still going to get negative, and then you have x cubed. So both of these look like the same cube. Thank you. Both of these look like the same answer, but the process was different. And that was probably a bad example for the book or WebAssign to use. But the idea was if you reflect about the x-axis, you're switching your y values, the sign of your y values. If you're reflecting about the y-axis, you're flipping based on your x values. If you had a different problem, it'd be a lot clearer.
Is there going to be both on the test? Because if the answers are the same, I mean,
Well-
I understand that getting to the answers.
Well, on the test, I would try to give something that was more obvious than x cubed.
Yeah.
Okay. Yes.
I get confused, like, when you have y equals, like, between, confused between stretching and compressing the graph vertically and between stretching and compressing the graph horizontally.
Okay. Verticals. Vertical stretch and compressing. Okay, vertical, that means in terms of your y values. All right, so this one turns out to be like you think. Your new function is just going to be a times your y, these are y values, f of x. So you're going to multiply it by a, where a is a number bigger than 1, such as if your basic function was y equals x squared, if you do y equals 4x squared, that's going to stretch. You take y equals x squared, and then your y values are now being multiplied by 4. You keep your same x, and it's going to stretch it. Compressing was when I had like weights on my arm coming down. Compressing is still y equals a times f of x, but your y values are going to have to be smaller to bring your graph down. So your a is going to be between 0 and 1, such as y equals 1/2 x squared. You got your same old x squared, but now your old y values are being multiplied by half. Okay, vertical is the one that makes sense. Horizontal is the one that seems confusing. All right, horizontal, you're working with your x values along the x-axis. And so to do a stretch, you're going to have to say, okay, horizontal has to do with x. So inside your parentheses here, you're going to have a ax, which really means that you've substituted a ax into your original function and you have already doubled it here, or whatever you've done. So when you're going to do a stretch, you're going to, it's just the opposite of what it looks like. Your old x is multiplied, who remembers? By what kind of factor? 1 over a. Okay, because that's going to actually stretch it out this way because you've actually taken your old domain and multiplied by a. So when you substitute in to do your stretch, you're really stretching it. To do a stretch, it's going to be by 1 over a. It's always backwards from what it says.
The same thing as doing a vertical compression.
Well, the picture looks very similar.
No, I'm just saying, because like in the same sense, you actually are, because you're doing 1 over a, and you have to put.
But it's backwards. The compressing here, the a was between. Okay, and see that was a compressing with a fraction, and here this was a stretching with a factor. Okay, the compressing horizontally, when you have y equals f of, usually what's in here is like a 1 over ax. This is a fraction between 0 and 1. If a is bigger than 1. There's a fraction in here between 0 and 1. And then that is going to compress it by a factor of A.
Can you give an example like you did for, no, I mean like just the y equals like you did for the vertical?
Yeah. Okay, f of x equals x squared. So if you say f of 2x equals 2x quantity squared like this, what that is when you graph this, it's going to be a compressing, because it looks like a stretch really. It's opposite sounding for your horizontal. It's a compressing by a factor of 1/2. And I'll just show you. If you multiply this out, well, let's just do it. 0, 0, 1, 1, and let's do a 2, 4 up here. And a negative 1, 1, and a negative 2, 4. All right, there's the graph of y equals x squared. Okay, so now if I'm going to graph f of 2x, the x values will be multiplied by 1/2. So it's going to bring it in. So now at x equal to 1, it's going to be at 1/2. At x equal to 2, I'm going to take I'm multiplying the x's times the x's by 1/2. So 1/2 of 1 is 1/2. So now I have 1/2 1. 1/2 times 1. So this is the point 1/2 1. I multiplied the OX by 1/2. This OX is 2 and it had a Y value 4. So I'm going to multiply that 2 times 1/2, which gives me 1 4. 1 4. Half of the 2 is 1 times 4. So compressing means it's shrinking it in closer to the y-axis, which looks like a vertical stretch, but you're working with the x values to bring it in. Does that show you what I'm talking about?
Yeah.
If you have f of x equals if you have f of 1/2 x, which is 1/2 x squared, that is going to take it and stretch it out this way by a factor of 2. And you'll go in there and multiply those old x values now by 2. So where you had an old 1, 1 times 2 is 2, so it's going to be the point 2, 1. It's going to do a stretch to pull it out away from the y-axis. Does that somewhat help? The horizontal, it seems backwards from what it is, but you're working on the x values. All right. Did I answer all those questions about compressing and stretching? I think I did. Reflect about x, y. Yep. I think I answered those. All right, there was another WebAssign question that was running several people crazy. And it was something like f of x equals square root of x. And you were supposed to write the equation for this that would shift up, say, 7. All right, so if you're going to shift this up 7, it's a vertical shift up of 7. It's going to be what?
Or f of x equals
Square root of x
Plus 7.
plus 7. Now, if the question had been, the next question, if it had been, I'm trying to think how I want to say this. If the question had been f of x equals square root of x, and you were told to sketch f of x equals minus square root of x, what would you do here?
Just reflect it.
All right, just be a reflection about the x-axis. It would come down like this. Okay. Now, the WebAssign question was different. The WebAssign question said, now take this function. All right, the WebAssign question said, take this function and reflect the whole thing about the x-axis. All right, so the web assigned question was this. It basically said take your new function that you've created and reflect this whole function about x-axis. Okay, it didn't want you to take this up and then reflect there. It wanted you to take this whole thing and send it across. So this function right here, as you know, looks something like this, where this is 7. Square root of x plus 7. It said now take this and reflect it all the way down here. So how are you going to write that function? Okay, the entire function. So the new function then, to get it down here with a reflection, which would look like this, is going to be minus that whole function, square root of x plus 7. Okay? And that is different, as you know, from minus square root of x plus 7, because you'd have to distribute your negative. Does that somewhat help with that web assigned question? It was saying take that function and then send the whole thing down. Is that good? Yeah.
So when you actually reflect it, it's going to start at -7?
Yeah,
Or-
yeah. In that particular web assigned question, it led you through a series of things.
Okay.
It said start with this function, shift it up 7. Then it said take that entire function and send it across the x-axis. So it was, the ones that we did so much in class was like negative square root of x and then a plus 7.
Okay, but it actually changed the whole
To change the whole thing. So that was a bit confusing there. All right, let's go to the book page. The rest of the questions were right out of the book, I think. Page 263, number 32. Page 263, number 32. Let's see what that looks like. 263, number 32. All right, you're supposed to sketch the graph and answer a bunch of questions of f of x equals x plus 3 whenever x is less than -2, and minus 2x minus 3 when x is greater than or equal to -2. All right, so we are going to sketch the graph and then we'll answer all those other questions. All right, what kind of function is this called? Piecewise defined function. Piecewise defined. So it just means multi-part. We're going to have several parts to this function. Okay, don't forget on the test you're doing good graphs. Label your axes. Indicate your units. Whoops, that's a 4. Indicate them correctly. Okay. All right. Now, the question that whoever asked this said was, well, I don't know where to graph this. So what we did in class was I suggested first that you graph good old y equals x plus 3. And as soon as you see y equals x plus 3, you know that's the graph of a line. Slope is 1, so you go up 1 over 1, or down 1 over -1 to get some points. And your line looks like this, which I'm doing lightly in pencil. Okay? But what does this part right here say?
It's got to be less than -2.
Yeah, it says get rid of everything you just drew except where x is less than -2. So I find where x is -2, and less than means in the direction of negative infinity, right? So I'm just going to go up here where x is -2 and put a little open circle and only keep that part of the line. I couldn't use a solid circle here because I'm getting as close as I can to -2. I forgot who asked me this, so let me be looking at your face. Was it you? How's that part so far?
Okay.
Are we okay so far?
Yeah.
All right, then let's go. So we'll just erase the rest of the line.
Can you show me how you got the line again?
Yeah, how did I get the line? When you have y equals mx plus b, the y-intercept is 3, slope is 1. So I went up 1 over 1 for slope, or down 1 over -1, negative over negative. The other thing you could have done quickly were x and y intercepts. X is -3 when y is 0, and I just drew the straight line. Okay, the next one is -2x minus 3. So -2x minus 3 has a y-intercept of -3, and the slope is -2. So that's -2 over 1, or the same thing as 2 over -1, correct? So, which way do I want to do it? I guess I'll go down to, I didn't have enough space on my graph, did I? All right, so I'm going to start at -3, and I'm going to go down 2 over 1. So if I go down 2 over 1, I'm here, go down 2 more, and I'm off the page. But basically, the line looks something like that. That's supposed to be a line. Okay, my units got off. All right, this says keep only, oops, guess we better go this way. So I'm going to go up 2, 1, 2 over -1. Up 2 over -1. All right, so my line looks like this. Okay? All right, this piecewise defined says find where x is -2. Well, when x is -2, the y value is +1, so it came in here actually and filled in this dot, because that's where x is -2, and it comes through like this. Okay? When x is exactly equal to -2, that's 4 minus 3 is 1, so that filled in that little open circle there and came down. Yes?
When x is bigger than negative or equal to -2.
Here's x is -2, bigger goes this way, and there's the graph.
So that little thing on the side tells you what to keep?
Yeah, that's your domain. This says when, it says graph this thing when x is less than -2. Graph this thing when x is greater than or equal to -2. Does that help?
Are there going to be a lot of these on the test?
What, your tests are not padded, so you have like one kind of question, and hopefully you don't get any more of those.
Okay.
All right, what's the domain for this function? What's the domain? All real numbers, because you've got every x value covered. You can see it right here. What is the range of this function? Range.
Less than 1.
Y is less than or equal to 1. Range, your highest y value is 1. The highest y value is 1, and it goes to -infinity.
What about the domain? How do you know it's all real?
The domain is x is all real, because every x less than -2 is covered. Every x from -2 on is covered, so it covered all your x values.
So you can tell that just by looking at the symbols.
That right there told you that all your x's were covered from right here.
And say the bottom one didn't have an equal to. You would just say all numbers, all real numbers greater than -2, or
All
all
real
real numbers except for -2.
Yes.
Yeah,
His-
that's what I was trying to say.
Okay, if that didn't get picked up on tape, his comment was, suppose it said x is less than -2 and x is strictly greater than -2. Then your domain would be all real numbers except -2.
Because it's not covered.
Right. And what's your range again? Range has to do with y. What's your greatest y value?
Less than or equal
One.
to 1.
Okay, so you can say y is less than or equal to, whoops, that's +1. How do you put that in interval notation? One's the biggest number, it's going down. How's that in interval notation?
1 to negative.
One.
You have to
one
go
to
from
negative
small
infinity.
number.
Negative infinity.
Negative infinity up to
One.
1. And there's a square bracket on 1 because 1 is included there. So it's 1 to negative infinity. Interval notation is always small to large. How did you put all real numbers in interval notation?
Negative infinity.
Negative infinity to positive infinity. Okay? Everybody good? Is that good on 263, number 32? We'll check that one off. Let's go to page 251, number 35. 251, number 35. Okay, this is page 251, number 35. All right, this has to do with the supply and demand. Who does the supplying and who does the demanding? The producer supplies and the consumer demands, and it's based on the price. Suppose that the quantity supplied is given by this number, and the consumer demands by this number, and P represents the price there. Oh, that goes to the top of the next page is the rest of the question. Top of the page. Where P is the price in dollars, the equilibrium price of the market is defined to be the price at which the quantity supplied equals the quantity demanded. What did I call that in class that nobody's? Happy point. You're willing to pay the price and you will buy, and the consumer is willing to produce at that price. Okay, so you're going to set the supply equal to the demand. That's the happy point or the equilibrium point. So how do you find the equilibrium point if your supply is minus 200 plus 50p and your demand is 1,000 minus 25p? So how do you find the happy point, also better known as the equilibrium point? What are you going to do, everybody?
Set them equal.
Set them equal to each other. This is where S is equal to D. Negative 200 plus 50p equals 1,000 minus 25p. When you solve this, you will know what P is. Okay? Find the equilibrium price. All right, now, once you know the price, okay, I'm going to assume you can solve this for P. I don't remember who asked, but you can solve this for P. So the first part said find the price. The next says find the quantity. Okay, so once you know the price, how do you go back and find the quantity?
Put it in.
And can you put it in either one?
No.
Yeah, because this is going to be where those two curves intersect, right? This is P, and over here you either have S of P or D of P. This is the two places where these curves intersected. So once you know the price, you can put it into either one of these, and that will be the quantity. They got to intersect there. They got to be at the same place. Who asked me this? So I'm looking at you. Oh, are you good? Mm-hmm. Okay. And is that enough of that question? Was that the part that you didn't understand?
Yeah.
You sure?
Yeah.
Mm-hmm.
Okay.
And
Who wants to ask me a question about this?
Can you work the whole thing? Yeah.
You know you don't need me to solve this simple equation for
No,
you.
not the equation, but the rest, like being.
Okay. All right. I think we're going to have to stop because I think we're running out of time, and we will pick up, I promise, at the beginning of the next tape with this problem. All right? We'll stop there, take a break. Okay, all right. We're back now with lecture 7B, we didn't quite finish answering all the questions that I had listed for test number 1. We have 2 more questions according to my list, and then we're going to move in, because we have to, starting with chapter 3, section 2. This is on polynomial functions. And we will start working in chapter 3.2. All right, at the end of the last lecture, we were on page 251 with number 35, which I started rushing through and then realized that it was really parts B and C that were the concern. All right, so what I want to do is go back. We're on page 251, number 35, and let's make a sketch of the graph, just so we can see what's happening here. Along this axis, we have P, and along this axis, we are having the quantity supplied or demanded. Okay, so we got a price. I'm just going to try to get a little idea what it looks like. S of P, the supplied is negative 200 plus 50P, so you're way down here somewhere on this axis, which basically means they're not going to start supplying until the price gets up. Negative 200 plus 50P, so this graph is going to go something like this. Okay, by the way, what's this intercept right here? I know it's the p-intercept, but when I graph this thing, what's the value here? What makes the supply equal to 0? And price is 4. 4 times 50 is 200, so this crosses at 4. Okay, so this means these people are not even going to start supplying until after the price is at 4, because this is the quantity. Down here really would be like they're coming in your house pulling stuff off your shelves, okay, because you're in the negative. So here's the supply curve. The producer is supplying. They're not even going to talk to you till you get past a price of $4, and then they start supplying. Do you see? Okay, the demand is 1,000 minus 25p, and let's see, 1,200, that's the intercept. All right, this curve is going to come across like this. This is up here at 1,000. That just means that the consumer would just go crazy. If the price was 0, they'd all be out there getting 1,000 of these. Of course, the producer is not going to supply at that level. All right. So here is where the curves cross, and this is where everybody's happy. This is the equilibrium. All right, so this is where your supply is equal to your demand. So the supply is negative 200 plus 50p equals 1,000 minus 25p. So we want to solve this. I'm going to add 25 to both sides. And I'm going to add 200 to both sides, right? And what is 1,200 divided by 75? 16? Thank you. So this is going to be, not drawn to scale, a price of $16. So the consumer is going to be happy to purchase at 16. The producer is going to be happy to supply him at 16. All right, let's find out what the quantity is. I can put it in either one, so I'll do S at 16 equals negative 200 plus 50 times 16. Can you tell me what that is? 600. Thank you. All right. So the point, the equilibrium point here is 16,600. That means when the price is $16, the producer is willing to supply 600, and when the price is $16, the consumer is willing to buy 600 of whatever this is. Okay? All right, so now let's go to B. Determine the prices for which the quantity demanded is greater than the quantity supplied. The quantity demanded is your demand equation, right? The quantity demanded is greater than the quantity supplied. Isn't that what the sentence translates to? The quantity demanded is greater than the quantity supplied. So where are you looking on your graph? Okay, so it's got to be somewhere at what price? Somewhere on one side of 16. So let's analyze your graph. This is the graph. I didn't even label my axes. This is D of P right here. I mean my lines. This is D of P, and this is, the green is S of P. I did label that one. Okay, so if I'm right here, for example, if I'm right here, is D of P greater than or less than S of P? D of P is bigger. You got bigger values. So when you are less than $16, the demand is greater than the supply. When you're bigger than 16, the supply is bigger than the demand. Does that make sense? The graph helps you visualize what's going on here. Is that clear, everybody? Okay. So the price at which the quantity demanded is greater than the quantity supplied, that would be when the price is less than $16. There's a bigger demand. And everybody's really happy if the price is zero. They'll just go out there and buy tons of the stuff at $0. All right, question C is a what do you think? When you have a what do you think, you can't miss it. What do you think will eventually happen to the price of t-shirts if the demand is greater than the supplied? Price will go up, right? Absolutely. Whenever you want all those Beanie Babies and there's a demand for them, they're going to jack the price up and see what the market will bear, right? Isn't that what it's called? What will the market bear? They're going to keep pushing and keep pushing, just like real estate at the beach right now. The prices are just going up, up, up to see what the demand, what the market will handle. Okay? Everybody good? All right, that was a great question. Thank you for asking me, and thank you for not letting me get off of it till we got it answered. All right, the next question and the last one is from page 283, number 8. Page 283, number 8. Page 283, 283, 283. Number 8. And this is our fencing problem. Right here. It's probably a WebAssign question, was it? Okay, probably on WebAssign. All right. We're going to put a field along a river. We had chicken pens along a barn as our example. Beth has 3,000 feet of fencing to enclose a rectangular field. One side of the field lies along the river, so you only need 3. That means that whatever animals they have in there won't go jump in the river and get out. Express the area of the rectangle as a function of x, where x is the length of the side parallel to the river. And then we want to graph it. This says using a graphing utility. You're not going to want to do that because now you know all about quadratic functions. Was that in section 3.1? Yeah, now you know how to do it without the graphing utility. Okay? All right, so number 8. Always helps if you draw a picture. I think a water is blue, so let's draw the water as blue. I'm off the screen. Oops, there we go. There's the water. That's the river. Maybe it's more than one dimension. There you go. All right, now we're going to put a fence right here. Whatever we have here is scared to get in the water. And we're going to put fencing all along here. And it says to one side, where did we label X? X is the length of the side parallel to the river. So this is X. And we'll just call this W for width. And all along here, we're going to use 3,000 feet of fencing. Somebody give me an equation here.
3,000
3,000
equals W plus length plus
2W plus
2W, yeah, 2W plus
X. Okay, so 3,000 equals 2W plus X. Right? All right, what kind of equation is this called? Constraint. Because otherwise I could have all the fencing I wanted. I'm restricted, I'm constrained to use only 3,000 feet of fencing. All right, part A says, express the area of this rectangle as a function of x. All right, in general, let's do a general, all right, area general. What's the area of a rectangle in general? Length times width. All right, now let's start focusing in on our graph. What is the area of this rectangle?
W.
W times x, or x times w. All right, so this is ours. And the problem says, I want you to write the area only in terms of x. Area only in terms of x. And when you look up here, there's a w. So I've got to find a way to replace w only in terms of x. So what are you going to do?
3,000.
Okay, you're going to go back up here to your constraint and solve for w. You're exactly right. So we have 3,000 minus x equals 2w. So w is equal to, what, 1,500? I'm dividing all the way through by 2 minus 1/2 x. Is that good?
Yeah.
Have you found your mistake?
Mm-hmm.
All right, so then this is going to come down here, and we have 1,500 minus 1/2 x. If you want to multiply that out, you're going to get 1,500x minus 1/2 x squared. All right, now this was before we really worked on graphing quadratic functions, but now you know all about this graph. What's this the graph of? Parabola. Along this axis you have x. Up here you have area. And this graph is going to open up or down? Down. And you know how to find the vertex, right? X is equal to negative b over 2a. And you know wherever that vertex is, that's where you're going to have the maximum area. And you know how to find the x-intercepts. Factor the big F word, set it equal to 0. So you know how to find it. But the question is, for what value of x is the area the largest? So every time you do negative b over 2a, you got it. Is that good? All righty. We are ready for test 1, and we're ready to move on. All right. We are now beginning test 2. Now, I'd only like A's on the test 1. Only A's. Work, work, work. Okay. 3.2 begins on page 318. And you remember in 3.1, which is also on your test tomorrow, you did linear functions. And now we're building on that, and we're going to move into polynomial functions. So let's look on page 318 at the objectives we're going to work with in this section. We want to be able to look at an equation and identify if it's a polynomial function, and we want to be able to state the degree of that polynomial function. Because really what is going to happen is we're going to start analyzing the graph. We're going to be able to talk about the long-term behavior of the graph, how many turning points does it have, etc. But before we get to more analyzing the graphs, we're going to have fun with some transformations, shift, stretch, reflect deal. And we're going to learn to talk about zeros of a polynomial function. Identify the zeros of the function. What do you think that means, zeros of the function?
Value.
Like when x is, or y is equal to 0.
Right. When y is 0, zeros of the function. When y is 0, so zeros of the function means I'm looking for the x-intercepts. What makes the function y equal to 0? And multiplicity, we'll talk about that. And analyzing the graph. We want to be able to look at a polynomial function and analyze what the end behavior is, what's going on there. Okay? All right, so the first thing we want to do is we're back to the end of chapter 3, and let's look at Are You Prepared? Take a second here. And we're going to look at number 1, 2, and 3. We're not going to use the graphing utility. All right, so let's divide up. This group over here, number 1 is yours. You 4. Number 2, why don't you 3 since you're together, and number 3 at the back. Number 3 is yours. Are you prepared on page 330?
We had number 2.
You've got number 2. I have number 3 at the back.
Where's the definition?
Yeah, you gotta turn it into
It goes along front.
a square plus minus 30.
I said I was trying to think this is what we're looking to see. What does it say, like the definition?
Negative 4.
They're real numbers. It's gonna be a B. Yeah.
You'll have a 50-50 chance to get it right.
Mm-hmm.
I'm going to ask you why,
Okay.
so be sure you know why.
Mm-hmm.
How to do the quadratic of this square.
I didn't even say anything.
Okay, y'all in agreement over here?
She should be doing the same thing we're doing. You doing the same thing? What have you got? Are y'all happy back there with yours answer? Y'all had an easy one, didn't you? That's too bad. Should have given you the hard one. Here's the answers.
All right, let's go with it. So this is, are you prepared? This book is really good to do things like this to send you back for the things that you need to be good at before you attempt this section. Okay, number 1, you've got 9x squared plus 4y equals 36, and you're asked to find intercepts. But I want to go a step further. What's the graph of this going to be if you were going to graph it?
Parabola.
A parabola. You're exactly right. It is a parabola. Can you tell me if it's going to open up or down? Up. You would need to rewrite this as y equals. Is it?
No, it opens down.
No,
Gonna
it's
go down.
It's going down.
You need to solve for y before you know. Minus 9x squared plus 36, so y is negative 9. 4 is x squared plus 36 over 4. So you got to be careful that to say if it's going to open up or down, you need it in the form y equals ax squared plus bx plus c. Okay, that was not part of the question. I just jumped there. All right, the first question part is the intercepts. Which one did you go with first? Y-intercept?
It's gonna be 9.
Okay, you let x equal 0. So if you let x equal 0, you get 4y equals 36. Y equals 9. Perfect. Okay, is that right? How do you find your x-intercept?
Use the quadratic.
You could, but well, you'd have to set that equal to 0. But I think it's going to be easier if you use your square root principle. Remember we mentioned that, where you have a squared equals b. A is equal to plus minus square root of b. Square root principle. Okay, because there's not any other x's in there, that's why it's going to be easier. So for the x-intercepts, let y equal 0. So you've got 9x squared equals 36, because you let y be 0. So x squared is equal to 36 divided by 9, which is 4. So x is equal to plus or minus square root of 4, which is plus or minus 2. Perfect. Okay? So if you don't have another x in there with the x squared, then I would jump on that square root principle and life would be great. Is that good? All right, let's go to number 2. And it was 4x cubed minus 3.6x squared minus square root of 2. The question is 50-50 guess. Is this a polynomial expression? Is this a polynomial expression? And you said no?
Well, yeah, false.
You said false? Why'd you say false?
They're not all real numbers.
The square root of 2.
Square root of 2 is a real number. It happens to be irrational. It's not complex numbers. Complex numbers are like a plus bi. Real numbers are your rational numbers, which can be written as a fraction, or anything that's a non-repeating decimal, such as square root of 3, etc. So there's not any I with that square root of 2. So it's a real number. So now, let's go back. Is this expression a polynomial?
True.
If it's not false, it must be true. All right, let's go to page 36 and 37. Because we got to know about polynomials before we can do polynomial functions. 36 and 37. 36 and 37. And if real numbers were a problem, you need to go back to R1 in your book, right at the beginning, where it talks about real numbers, defines a real number right at the beginning. Real numbers is on page 2 of the book. Go back and look at those. Okay, so 36 and 37 is where it's talking about what a polynomial expression is. Page 36 in the book. A polynomial in one variable, so you only see x's. An algebraic expression of the form. So here's the form. It looks like you got an x to the n minus 1. Your exponents on your x are decreasing by 1. Okay, the numbers in front of the x's are constants. Those are called coefficients of the polynomial. And n has to be a number greater than or equal to 0 and an integer. So if it's an integer greater than or equal to 0, let's count those off. That would be 0, 1, 2, 3, 4, 5. So that means the exponents on the n have to be numbers like 0, 1, 2, 3, 4, 5. And the a's here are constants or real numbers. X is the variable. Okay, if a sub n, that first number right here, is not equal to 0, we're going to call that the leading coefficient. And the n of that term is called the degree of the polynomial. All right, so a polynomial expression is just, doesn't have an equals to in there, so it's not an equation. It has x to the n powers, where n's are the numbers 0, 1, 2, 3, 4, 5, and a's in here are real numbers. Okay? And each of these little parts are called terms. Okay. What else? Monomial, okay, it has terms added together plus separate terms. If all the coefficients are 0, the polynomial is called a zero polynomial, which has no degree. Okay? All right, standard form. So here are some examples right under here. Notice that the exponents are integers. Your coefficients are the numbers in front of those x terms. Now, to find the degree, you find the highest power on the x. For this first example in below here of the polynomial, what is called your leading coefficient? Which one's the leading coefficient here? Negative 8, because it's with the term of highest power. Okay. The second example here, not quite sure why they put all these little equal to's in here. Wonder if that was, I'm not quite sure why they did that, because we were talking about polynomial expressions. If you look down here a little further, here's a polynomial expression of degree 4. Of polynomial in terms of x. It says in terms of x. Here's one in terms of y, it's a third degree, and here's one a fifth degree in terms of z. And pi is a irrational number, just like square root 2 or 3 or whatever. All right, so there's some polynomials. Okay, so to answer our question back on whatever page we were on, 3.2. This is a polynomial expression, 4x cubed minus 3.6x squared minus square root of 2. It is, so that's true. What is the degree of my polynomial expression? 3. And what is my leading coefficient? 4. Okay? So we need those things. All right. So it's degree 3, leading coefficient is 4, third degree. And all the constants here have to be real numbers, and square root of 2 is a real number. Okay? That was number 2. All right, number 3, a little bit too easy. The graph of y equals x squared minus 4, in order to graph that, you would shift the graph of y equals x squared how? Down 4 units, a distance of 4 units. So this is just a graph of y equals x squared, shifted down 4, and we got the good old graph y equals x squared here. Okay? Everybody good on that? All right. So that was a polynomial expression that you just reviewed. Now, what do you think makes a polynomial function? What makes it a function? It's got f of x in it. Exactly right. So I'm back on page 318. And now we want to start talking about functions, which means we have some y value, or f of x. Now that looks almost like the expression you just looked at on page 34, except now we have f of x equals. All right, now notice that the coefficients, the little a sub n's, those are real numbers. N is non-negative. Well, non-negative means 0, 1, 2, 3. Non-negative integers, 0, 1, 2, 3. And of course your domain is all real numbers. Okay, the degree of your polynomial function is the degree of the polynomial in one variable, and it's the largest power of x that appears. Largest power of x that appears. Okay? Everybody got it? Polynomial function. So we need to know, well, what is and what is not. So I decided let's just flip over here to the exercises. I'm on page 330. And we're just going to say this in unison. I'm on page 330. Can you see them? Here, I'll slide the book so they can focus in. All right, number 11. Would you say that's a polynomial function? Number 11. Who said no? Was that just a slip, or had you not looked at it carefully?
I thought it had to be in order.
No, you got two terms, so your commutative property says you could write that as x cubed plus 4x. So the order that you write the terms, it doesn't matter. Okay, so, all right, so this is a polynomial function. What's the degree? 3. What's the leading coefficient?
4.
1. Let's go to problem number 12. Is this a polynomial function?
Yes.
What's the degree?
4.
4. Leading coefficient?
4.
4. Okay, let's go to number 15. Number 15, is that a polynomial function?
No.
No, absolutely not. I'm going to write in this book. If I were trying to make it look like a polynomial function, I would rewrite that as 1 minus x to the negative 1 power. Remember that negative exponent means take the reciprocal. And when you look back at your definition, you're trying to write it as x raised to some power, not 1 over x raised to some power. So first of all, you got to write it as x to the n, and then the thing is n has to be non-negative integer. So if I'm trying to write it as x to some power, it has to be x to that negative 1. So that is not a polynomial function. Somebody tell me what kind of function that is. Well, it does look like a reciprocal function, so that's okay. It's also called what else? Rational function. Okay. What about number 13? Do you think that's a polynomial function? Yeah, what's the first term here? 1/2 minus 1/2 x squared. Okay, so what is the degree of number 13?
2.
And the leading coefficient?
Negative 1.
Negative 1/2. Let's flip over to the next page, page 331. 331. What would you say about number 17? Would you say that that is a polynomial function? Why would you say no?
Exponent.
That exponents are 3/2, and the rules is the exponent has to be 0, 1, 2, 3, and that 3/2 is really a square root cubed, right? 3/2 power square root cubed. So that is not a polynomial function. Not a polynomial function. Everybody got the terms? Got the terms? Know what a polynomial function is? All right. Oh, well, while we're at it, let's look at number 19. Would you say 19 is a polynomial function?
Yes.
Yes, because you got 4 on the x, a 3 on the x, and the 1/2 is really like times x to the 0. And the coefficients are all real numbers. Pi is a real number. It just happens to be a non-repeating decimal. Okay, so 19 is a polynomial of degree 4. Okay, good. All right. The next thing in section 3.2, a lot of this seems to be vocabulary, is we want to start out with just looking at power functions of degree n. Power function of degree n is just a special polynomial where we're only going to have one term. We're just going to have one term, and it's going to be ax to the n. And we're going to use this to help us talk about long-term behaviors of other polynomial functions. All right, so what I'm going to do, we're looking at power functions. And this is the polynomial function ax to the n. So first thing I'm going to do is look at when n is odd. When n is an odd number. And we're just going to pick a equal to 1 to start with. Okay, n's an odd number. That means I want to look at functions like f of x equals x cubed, f of x equals x to the 5th, f of x equals x to the 7th. And of course I could look at f of x equals x to the 1st. 1, 3, 5, 7, those are your odd numbers. All right, so I went to Maple and decided to plot these. Okay, I went to Maple and decided to plot these. In blue, I have y equals x cubed. Okay, there's that part right there. In red, I have y equals x to the 5th, and in green, I have y equals x to the 7th. All right, so just looking at my graph, along the x-axis I went from -2 to 2, and it looks like the y-axis goes about a -100 to 100 here. All right, as x approaches infinity, this says as x approaches infinity, as x gets bigger and bigger and bigger, what do you think the y value is going to approach? These curves are going to continue on going off forever and ever. What's the y value going to approach as x gets bigger and bigger? You can just look right here using any of these curves. As you put a big value in for x, like 100, 1,000, 10,000, what's happening to the y values?
They're going to go up.
They're getting bigger and bigger too, right? So we would say y approaches. This little arrow right here means approaches. Approaches. So our long-term behavior for these graphs, y equals x cubed, y equals x to the 5th, y equals x to the 7th, the long-term behavior says, well, as x gets really, really big, those y values are just getting bigger and bigger and bigger. Tell me, as x approaches negative infinity, as x gets smaller and smaller and smaller, where do you think these functions are headed, the y values? Negative infinity. All right, now if I have x cubed, x to the 5th, x to the 7th, what do you bet x to the 9th is going to look like? It's going to look similar, but it's going to go up quicker and go down faster. What about x to the 99th power? It's going to have kind of the same curve. All right. Well, I took this because it looks like these curves are really on top of each other between what numbers? -1 and 1. We can't see what's happening in there. So then I went back and did the same graphs, but I just graphed between -1 and 1. Between -1 and 1. Okay, and I still have the same thing. Y equals x to the 7th is the green. Now notice, after 1, y equals x to the 7 went up really fast. Okay, but between 0 and 1, the x to the 7th is underneath. That's because you're raising a fraction to a 1/2 power. Aaron, I want you to move on the back row and don't ever sit beside anybody in this class again.
Sorry.
Move right now. Every day I've had to say something to you. Right? So after 1, x to the 7th just gets bigger and bigger and bigger. But between 0 and 1, it's going to be closer to the x-axis because you're raising a fraction to the 7th power, like 1/2 to the 7th. That's a very small number. 1/2 times a half times a half times a half, etc. Very small number. So what happens is it's very flat, and then after 1 it goes off very quickly. Y equals x to the 5th, it's going to go off, but between 0 and 1, it's going to be a little bit bigger than x to the 7th, because if you raise a half to the 5th, that's a bigger number than a half raised to the 7th power. Do you see how that works? All right, so we know that if we were going to graph something like y equals x to the 29th power, the long-term behavior is the ends of the graphs go in opposite directions. It's going to be a little flattened out between -1 and 1, and then they're going to fly off like this. Everybody got it? So if it's an odd power, the ends go in opposite directions, and the bigger the power, the flatter it's going to be between -1 and 1, but then it's going to fly off. Okay? All right, let's look at even powers. Even powers. Okay, in green, green we have y equals x to the 6. In red, I have y equals x to the 4th. And in blue, I have y equals x squared. All right, and I graph this time between negative 1.5 and 1.5. Okay, y equals x squared. By the way, what points are common to all three of these graphs? 0, 0, what else?
1, 1.
1, 1,
Negative
and
one.
negative 1, 1. Okay, but if you're between negative 1 and 1, y equals x squared is bigger than y equals x to the 4th, which is bigger than y equals x to the 6th. Can you see those colors in there? And again, the easy point to pick is let x equal a half. A half squared is greater than a half to the 4th. Okay, but after 1, x to the 6th flies off faster than x to the 4th, etc. Everybody good? Okay, let me ask this question. As x approaches infinity, what does y approach? As x approaches infinity, what is the y value of these functions approaching? Infinity. What about as x approaches negative infinity? It's going to still approach positive infinity. If you have a power function and the exponent is even, the ends of the graphs are always going to go the exact same way. Always the same way. If it's odd, opposite directions, even, same direction. Okay? Yes?
So is that because on the odd, one's going down and one's going up, and in that one they're both, that's why they're always going to be approaching positive infinity?
Yeah, if it's an even number, and of course your coefficient here would have to be positive. If it's a power function, the ends of the graph, if it's even powers, your highest power, your polynomial, the ends will always be going up. If it's an odd power, they're going to always be going opposite directions. Okay? All right. So let's work on a couple transformations. Would you like, let's just pick one directly from the book, or shall I make up one? Let's do one right from the exercises so you'll have something to work from. Page 331. And I am on page 331, problems 23 through 36. Look over those problems and let's just pick one that you would like to graph. We'll do one with an x to the 4th because that's even, and we'll do one with an x to the 5th because that's odd. So pick one with x to the 4th that you would like to do. You name it. 26?
33.
33? Let's do 33 because it looks the hardest. All right, let's do problem number 33. Okay, so this is page 331, number 33. F of x equals 2 times x plus 1 to the 4th plus 1. Okay? All right. What's your basic function? We're going to do transformations and analyze this thing. X to the 4th. And what does the graph y equals x to the 4th look like? Almost looks like the parabola, doesn't it? All right. Then what is this 2 going to do for you?
Stretch it.
Stretch. Vertical.
A vertical stretch. Vertical stretch by factor of 2. Okay, then what about y equals 2x to the 4th plus 1? I'm building this function here. What's that going to do, that plus 1?
Shift to the right.
It's a horizontal shift up 1. And now we got y equals 2 times x plus 1 to the 4th plus 1. What's that part going to do for you?
Horizontal.
Yeah, vertical.
Vertical. Sorry, vertical up there. What's this one going to do?
Horizontal to the left.
Horizontal to the left. To left 1. Okay, are we ready to graph? And I just got notice that we got 5 minutes max. All right, we'll get this done. Actually, I'll draw it on blue. Does everybody agree with the analyzing of the problem? So because it's an x to the fourth, we know the ends are going to be going directly straight up. Okay, 1, 2, 3, 4. Okay, so we're going to start out with y equals x to the fourth, 0, 0, 1, 1, negative 1, 1, and we're just going to kind of flatten it out between negative 1 and 1. Everybody good with y equals x to the fourth?
Mm-hmm.
Okay, now we're going to do some vertical stretches. So that's 1, 1, 0, 0, negative 1, 1. Okay, if we do a vertical stretch by a factor of 2, what do I do to these y values?
Multiply.
Y'all are so good. We're going to have good grades on that test. We're just affecting the y value. So 0 times 2 is still 0. 2 times 1 is 2, so now I have 1, 2. The y value is multiplied by 2. And negative 1, 2. Okay, I just multiply. It's a vertical stretch, so the y values are multiplied by 2. So this is y equals 2 times x to the fourth. Okay? All right, now the next you told me was a vertical shift up of 1. Shift up of 1. What am I going to do now?
Add 1.
Shift up 1. What am I touching? Vertical shift up.
The y-axis.
Y, you're going to add 1 to the y values. So we'll come through here and add 1 to the y values. So now we'll have 0, 1. And now we'll have 1, 3. And we'll have negative 1, 3. Okay? This is y equals 2x to the fourth plus 1. Okay, now I need another color. We'll go with black for our grand finale. Now we're going to go horizontal to the left 1. Horizontal means which values am I working with? X's, and so we'll subtract 1 from those x values. So I'm going to subtract 1 from those x values. Okay? So now I'm going to have negative 2, 3. I've come over this way 1. So I have negative 2, 3.
So horizontal, like if it says plus 1, you're supposed to do minus 1.
Yeah, anything to do with the x's always seems backwards from what you say. All right, now we have subtract 1 from 0. We're at now, that point is negative 1, 1. And we'll subtract 1 from this, and that's going to be 0, 3. Subtract 1 from that 1. Is everybody following those numbers? And the graph looks like this. All right, and because I only have 1 minute, let's just double check a point real fast. X at negative 2, that would be negative 1 to the fourth is 1. 1 times 2 is 2. 2 plus 1 is 3. Check. See it? And negative 1, 1, a negative 1 in here, that part's 0, and then we got plus 1. That's going to check, and I'm going to have to quickly stop because we've run out of time. Remember, this is on your test 2 material. Make it a great day, and we'll pick up here after the test.